Hi, this is Guillermo Campitelli, and in this video I'm going to talk about joint probability, marginal probability and conditional probability using a probability grid. And this probability grid, it combines a table, a traditional table, with components of the drone delivery metaphor that we've been seeing in the previous videos. Okay, so let's see this probability grid. Basically, it's a grid with two margins, the bottom margin and the right margin, and the internal cells are these four. So basically the margins are representing what we are going to see in the rest of the in the future videos as variables. So old and new are two values of the variable age. So age can take two values, old or new. And we've got another variable which is location, and it can take two values as well, inland and coastal. So basically what we've been doing, and we are going to continue doing now, is to combine values of variables, or sometimes considering one variable at a time. Like for example, so in this grid we've got first these marginal probabilities. They're called marginal probabilities because they are in the margin of the grid. And so basically when we talk about marginal probabilities, we are considering one variable at a time. So the marginal probabilities of the variable age have to add to 1, and they don't consider the probabilities of location. So basically we know that the probability of old given k, which is background knowledge, plus the probability of new given background knowledge must be 1. Yes? And because we are ignoring the values of the variable location. Same, if we are considering location, marginal probability of location, we know the probability of inland given background knowledge plus the probability of coastal given background knowledge should also be 1. Okay, so then we have the joint probabilities. So the joint probabilities, they combine the values of the variable age and location. So we've got two values for age, two values for location. So a full combination of values will give us 4 values. So here is old and inland, old and coastal, new and inland, new and coastal. So the joint probabilities, these 4 should add to 1. So we've got the marginal probabilities in this bottom margin should add to 1. These marginal probabilities in the right margin should add to 1, and these 4 joint probabilities should add to 1. Okay, now, and this is graphically, and we are going to use the graphs that we use for the drone delivery metaphor to use in this grid. Now these things, I'm going to use them just as a tool. They don't mean anything. You are going to see how I use them a bit in a second. Okay, and probability of Z is the total probability, or which should be 1. Okay, so let's for the time being ignore the variable age. Okay, so basically we are considering the marginal probabilities of inland and coastal given background knowledge. So we know for the previous videos that is 0.5 for inland and 0.5 for coastal. Okay. Now, based on these marginal probabilities and conditional probabilities, we can generate the joint probabilities. We've seen that in the drone delivery metaphor, and we are going to see in a different way in here. So let's see the following grid, and I'm going to hide this now. So basically we generated the two marginal probabilities for inland and coastal. Now actually I'm going to hide this as well. So and now we are going to consider conditional probabilities. So we are conditioning in that the drone landed in an inland region. Okay, so it landed in a yellow area, which is an inland area, and now these two probabilities, these two in red, they are the conditional probabilities. They should add to 1, because now we are not only ignoring we are ignoring the coastal value. We are considering only the landings in inland, so that we are considering the possibility that the drone landed in the inland region. So if we know the drone landed in the inland region, then there is a 60% chance that it landed in a new area, and 40% chance that it landed in an old area. Okay, so given that we know it landed in inland, then the probability of old given inland is 0.4, and the probability of new given inland is 0.6. And if we multiply the marginal and the conditional, we obtain the joint, and we've seen that with the product rule. So we saw the marginal probability of inland times the conditional probability of old given inland equals the joint probability of old and inland. So 0.5 times 0.4 is 0.2, and 0.5 times 0.6 is 0.3. Okay, so now these two joint probabilities, 0.2 plus 0.3, they add to 0.5. Yeah, and these two, which are conditional, they add to 1, because they don't take into account possibility of landing in the coastal area. Now let's consider the coastal area and ignore inland. Okay, so if we know the drone landed in the coastal area, there is an 80% chance it landed in an old region, and a 20% chance that it landed in a new region. Okay, so if we multiply the marginal times the conditional, we get the joint. Same again, 0.5 times 0.8 equals 0.4. 0.5 times 0.2 equals 0.1. Okay, the marginal times the conditional is equals to the joint distribution probability. And again, if we are conditioning in coastal, then the two conditional probabilities should add to 1. 0.8 plus 0.2 equals 1. Now, if we are considering the joint distributions, probabilities, then we've got 0.4 plus 0.1, they should add to 0.5. Okay, so basically, using that procedure, now we've got we've got the 4 joint probabilities, and the 4 joint probabilities should add to 1. So 0.2 plus 0.3 is 0.5, plus 0.4 is 0.9, plus 0.9 equals 1. And you can see that in these 4 cells we've got the areas of the city that we've been using in the previous videos. Okay, so now we should get the same result if we start with the marginal marginal probabilities of the variable age instead of the variable location. Okay, so instead of ignoring age, we are going to ignore location. Right, so let's consider these for the time being. Probability of old is 0.6, probability of new is 0.4. So these probabilities ignore the variable inland and coastal, the variable location with the values inland and coastal. Okay, so if we now condition as well on old, so we consider that the drone landing in old, then there is a 60% chance that it landed in a coastal region, and 33.3% chance that it landed in an inland region. And if we do the marginal times the conditional, gives us the joint. So 0.6 times 0.6666666 equals 0.4, and 0.6 times 0.33333 equals 0.2. Okay, so now we condition on new, therefore we ignore old. So if we condition if we know that the drone landed in a new region, then there is a 25% chance it landed in a coastal region, and 75% chance that it landed in an inland region. So again, if we multiply the marginal times the conditional, it gives us the joint. 0.4 times 0.25 equals 0.1, and 0.4 times 0.75 equals 0.3. Okay, and if we consider the conditional probabilities, we are conditioning on new. Basically, these two conditional probabilities should add to 1. 0.75 plus 0.25 equals 1. Same with the old. The conditional probability should add to 1. 0.333 plus 0.66666 equals 1. And the joint probabilities, 0.2 plus 0.4, they should add to the marginal probability of old. And here 0.3 times 0.1 should add to 0.4. Now, if we consider the 4 joint probabilities, 0.2, 0.4, 0.3, and 0.1, they add to 1. So we achieve the same result, but we started in calculating the marginal probabilities of the variable age, and then conditioning in the values of age. Okay, so as a summary, the grid helps us understand the marginal probabilities, the conditional probabilities, and the joint probabilities all in one grid, which is difficult to do. So basically, one thing that I want to add here is that we've got the marginal probability of the variable x, call it x, and the marginal probability of the value 1 of the variable x, and here the marginal probability of value 2 of the variable x. Now here I put x1 or x2, and that is an application of the sum rule. We said that the probability of x1 or x2 equals the probability of x1 plus the probability of x2 minus the joint probability of x1 and x2. But here we know that x1 and x2 are mutually exclusive events. So if they're mutually exclusive events, then their joint probability is 0. So x1 or x2, the probability of x1 or x2 equals the probability of x1 plus the probability of x2, and we don't have to subtract the joint probability because the joint probability of these two events is 0. Same here, marginal probability of y1 and marginal probability of y2, we add them together gives us 1, but we know by the sum rule that we need to subtract their joint probability, but we know they are mutually exclusive events, so their joint probability is 0. So subtracting 0 gives us the same result. So from each of the marginal probabilities we calculate the conditional probability, and we multiply the conditional probability times the marginal, then gives us the joint. We can go this way first, and then there, or we can go this way first and then there. Okay, thank you.